Alright, here we have the mass of Earth is 5.9742 times 10 to the 24th kilograms. So the mass of Earth is extremely large. Jim has a mass of 60 kilograms. The distance between Jim and the center of the Earth is 6.378 times 10 to the 6th meters. What is the force of gravity between Earth and Jim? Well, there's a few things we need to know first. There's this gravitational constant, capital G, that is equal to 6.673 times 10 to the negative 11th. Okay. And we also need to know the equation for the force of gravity. The force of gravity is equal to this capital G times the mass of the first object multiplied by the mass of the second object over r squared. And this r squared is the distance between the centers of the two objects. So in order to find the gravitational force, we plug in this number for G, 6.673 times 10 to the negative 11th, and that is being multiplied by the mass of Earth, which is 5.9742 times 10 to the 24th, and that's being multiplied by 60, and that's over 6.378 times 10 to the 6th, and that is squared. So let's go ahead and plug that into our calculator. Alright, first we have the gravitational constant, which is 6.673 times 10 to the negative 11th. And we can multiply that by 5.9742 times 10 to the 24th, which is the mass of Earth. We can multiply that by Jim's mass, which is 60, and then divide by 6.378 times 10 to the 6th squared, and we get 588. So the force of gravity between Jim and the Earth is 588 newtons. Now let's consider this. We know that force equals mass times acceleration, right? So what if we tried to calculate the acceleration of the Earth on Jim? So if we plugged in this force for the force of gravity, and then used Jim's mass to calculate for acceleration, what do you think we would get? We could divide both sides by mass, by Jim's mass, to find out the acceleration of the Earth on Jim. So acceleration would equal force over mass, which would be 588 over 60. Let's go ahead and plug that in. 588 over 60, and we get 9.8. Interesting. 9.8 meters per second squared. Does that look familiar to you guys? You should be thinking that this acceleration is the acceleration due to gravity, which has everything to do with the gravity and the force of gravity we're trying to calculate here. How do you like that?